If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are building concepts on parabola. Today we will see the concept of perpendicular tangents to a parabola and we will see its director circle. Okay, then let's see this. Okay, the topic is perpendicular tangent to a parabola, and that will lead to us a director circle, because we have seen what is director circle. From the director circle, in case of circle, we can draw two tangents and both the tangents were perpendicular to each other. So that is why perpendicular tangents are related to your director circle. Now you see what we have seen just now for focal chord. In case of focal chord T1, T2, these two product T1 and T2 product is -1. So you can write it in this way also. 1 by T1 into 1 by T2 is also -1. That will also keep you same, because -1 by 1 is also -1. Now what is 1 by T1? This is very interesting. And 1 by T2. This one we have started parametrization of parabola. We have seen this interesting. If T is a point, then 1 by T was the slope of the tangent and -T was the slope of the normal. These important things you have to remember. So -1 by T1 and 1 by T1 and 1 by T2, these are nothing but the slope at T1 and T2. So you have 2 points T1 and T2, this parabola. So these two product is -1, means you draw a tangent at T1, you draw a tangent at T2. The product is -1, means they are perpendicular. For now you see this one, where it is intersecting, that will come later. So this is the good finding that we have seen. So a focal chord, so we can say the tangents drawn at the extremities of a focal chord of a parabola are right angles. So if you have a focal chord, any focal chord, you take this focal chord. So if you draw the tangent, two tangents, they will meet at an angle of 90 degree. My drawing is not so clear, so that's why it is not coming at 90 degree, but it should come. Okay. Now we know. Now what another thing you know, that two tangents T1, T2, they intersect at this point. This is the intersection of two tangents and two normals. We have also studied this one. For tangents it was AT1 T2, AT1 plus T2, and for normal it was 2A T1 square T2 square AT1 T2, and then AT1 T2 minus AT1 T2 under bracket T1 plus T2. Both these were there. So for normal, for tangents, the intersecting point is this one. If you know tangents at T1, T2, directly you can write the intersecting point. But here T1, T2 is -1. T1, T2 is -1. So the intersecting point is -a comma this. So now you can see the x coordinate, that is the -a. It doesn't depend on T. For whatever value of T1, T2, whichever point you go, T1, T2 change means you will be changing the points. You are changing this point. Wherever point you go, this will always remain -1. That means x equal to always -1. That is nothing but directrix. So this point where it meets, that is nothing but -a comma AT1. So this height can change, AT1 plus T2, according to, if you change T1, T2, this height will change. It can come down, it can come up, but its x coordinate, that is always in -a. So it will be always in this line. So you can say the perpendicular tangents meets at directrix. So very good understanding again, very good conclusion. Then the perpendicular tangents intersect at this point, which is nothing but directrix. So we can say now the locus of the point of intersection of perpendicular tangents to a parabola. Why it is perpendicular tangents? Because if you multiply, then it is become -1. That's why both these are perpendicular. That one we have seen. So the point of intersection, locus of point of these perpendicular tangents in the parabola, because all the points will be on this line also. So the locus means if you add all these points, that will give you this line. So the parabola is, it is directrix, which is nothing but the director circle of the parabola. Very funny thing, although we are saying director circle, but it is a line. The director circle of parabola is a line, not a circle. So and what is that equation of that director circle? It is nothing but a directrix. Directrix, whatever the equation of directrix, here it is x equal to -a. If the shape changes, accordingly directrix also changes. We have seen 4 different shapes. If you like the video, then press the like button and please give your valuable comments in the comment section.